So it sounds kind of tricky the way it's wording it, but it's something you should be able to do. What it's wanting you to do is take the first statement and solve for x. Find what x is based on that relationship. Once you know x, can you evaluate this thing over here on the side? Sure. Substitute x in to the new statement and then figure out what that thing's equal to. So even though it's wording it, guys, it's like two problems in one. The first thing I want you to do is solve for x. So find what x is equal to. The second thing, they want you to substitute x into this equation that's telling you to evaluate. We have to use this for the first step to solve for x, right? Let's simplify this thing and try to get x by itself. What's the first thing you guys see? Simplification-wise. What should we take care of first? Parentheses? Yeah. Let's take the negative and distribute it. So negative 6x minus 7. I'll just recopy everything else. We can put more stuff together, right? 12 minus 7 gives me, it gives us what? 5? Something like that. So far we've done nothing new, we just put stuff together. Okay, x is on different sides. Let's move one to the other side. Which one do you want to move? The 6? So when I move it over, it becomes a positive 6x. That was messy. I'm going to write it again. So we got a positive. I'll write it below, I guess, anyway. Positive 6x, because technically, guys, if I wrote it on both sides, you were adding 6x on both sides to make the thing move. 6 minus 5 gives me x. Right? Everybody okay? Leon, you okay? What's up? Yell at me if you're not, because I need to know. Okay. I tried to write the two different methods. I haven't figured out what you guys like best. So the first thing I did, I drew the arrow and just said, you know what, move that over, change the sign, it becomes positive 6x. If you wanted to show yourself the steps again, the entire piece was negative, so what you really were doing is saying plus 6x, same thing both sides. Whichever way you want to look at it, that's where the 6x came from. It cancels over here on the right. A negative 5 and a positive 6 gives me a positive 1x. Let's change this to plus. And then we have a 9. To get x by itself, what shall we do? Yeah. The 9's attached by an and, so we look at the sign on it and just do the opposite. What's x equal to? Are we done with this problem? No, we did step 1. The step 2 says, hey, evaluate. So let's do that. Let's evaluate. That's another word for find a number for this thing. X squared minus 3x minus 2. So substitute this in. Let's see, we know we're solving with that negative 4 better go in parentheses, right? Minus 3. Something like that. Negative 4 times negative 4. Careful. Positive 16. That's why we had to be careful with the parentheses, though, because so that we would know that it was a positive, since they canceled. If I rewrite, I'll write out all the steps. You guys don't have to, but I'll do it just for kicks. So order of ops, that exponent was my first thing, since I didn't have any parentheses. Please excuse my dear Aunt Sally didn't go away. We didn't have parentheses, we had exponents, so we did those. Multiplication or division. Yes, negative 3 times negative 4. Positive 12. Now I just have add and subtract, the last section on this. So work left to right. 16 plus 12 gives me 28. Bring down that minus 2. We actually have 26. So the answer to this problem was actually 26. That's what the back of the book will say, even though you had to do so much more work to get there. I just wanted to make sure you guys would be okay when you see this. The other thing you might see is the use of formulas a little bit. Look on page 104. I'm going to do one of these examples, and I'll let you guys work. Page 104, let's look at number 144. Okay. An adult and a child are on a seesaw 14 inches long. The adult weighs, so we have seesaw. Write that down. Seesaw 14 feet long. The adult weighs 175 pounds. What I'm doing right now with you guys is just writing down all the data. I'm not doing anything organized. I'm just trying to see it without so many words. The child weighs 70 pounds. So I'm going to write child, 70 pounds. How many feet from the child must the fulcrum be placed? So feet I guess that's right, how many? I'll stop being so lazy. How many feet from the child must the fulcrum be placed? To balance? Are you kidding me? They better tell me some more. Oh, they do. Look at the directions, guys. They give me the equation for this whole balancing stuff, the hard part of this. What's the balancing equation for a seesaw or anything else using a fulcrum? You know, that thing where you have a plank or something and you have a centerpiece that it pivots over. What's that equation? So some kind of F1, I'm going to tell you that means force. Times X is equal to some other force, also known as maybe a weight or something, right? Something pushing down on the seesaw, times D minus X. This is another force. And then basically it's just saying, hey, that's the rest of the distance over here. So D would be the distance. And what X will tell us is how many feet from whichever one we're referring to. The child in this case, right? So when we're looking at it, do you guys want me to try to draw you a picture or just kind of plug in the stuff and work through it? What do you want to see? Let's look at it together, because to me it looks hard right now. So here's our seesaw, right? Here's our little fulcrum thingy, our balance point. And this is what we have. We know we have some kid sitting on the end of it, a 70-pound kid. And that's going to weigh it down. That's a force, right, on one side. We know on the other side we have some adults. That's 175 pounds. So they're weighing it down over here. Because it says from the child, I'm going to use that as my main focus point. Because it's asking me, what is this distance from the kid to here? What do you guys want to let distance be? What letter? Really? See, normally what they want us to do, I mean, D works as a distance, but really what they want us to do here is use this as the unknown part. So really, how many feet from the child is supposed to just be like an X. Sorry, I guess I shouldn't have asked you if it wasn't really an option. So this distance we don't know. We'll use X as a variable since that's what we use a lot, and it's in the formula. From this kid to the fulcrum. And then it says, you know what? So this leftover part, it's whatever the length of that is, right? What's the length of it? 14 feet. Minus x. Remember the logic is because, like, if you know this is the entire amount, if this were 14 and this were 5, what would this be? If this were 14 and this were 2, the x were 2, what would the right-hand side be? So the idea is, the reason we have the formula written like this is because whatever this length of the blue bar is, you're going to always take that, the 14 feet, and subtract off your x, right? Subtract off the distance between, in this picture, the kid and the fulcrum. That's why I'm drawing it like this. You guys okay? I didn't have to draw it. I just want you to see a picture. The idea, though, is we plug into this formula we've been given. The force of the kid, the weight of the kid, that's a 70, right? So I'm going to plug it into F1. We have x, which we don't know. We don't know the distance between the kid and the center part. That's equal to the second force, 175, times that 14. That was the distance, that was the length, right, of the entire thing, minus the x that we're solving for. Because we're trying to find when the thing's equal, when it's not going to be weighted, it's going to be exactly flat. So when is this side equal to this side, is what we're doing. That's what the formula does for you. You'll be given this formula if you're ever expected to use it, okay? All you would have to be able to do is plug in both weights and plug in the d for the distance. Notice that for the first force, I use the kid because that's what we're talking with respect to. We're saying from the kid, so the kid's going to be my first force, the main one. Then you just do the algebra you've learned. At least once you get here, you guys can handle it, right? What are you going to do? Okay, what do we get? Minus 175x, that sounds good. Then we have equals 70x on the left. Okay, we have x's on both sides. What do you guys want to do? How do you like to think about it? Do you like to think about it as just moving the x or as adding or subtracting on both sides? Okay, so which one do you want to move or get rid of? 175, okay. So to cancel it or to move it, you add it. Since that's the opposite of how it's attached. What you do to one side, you must also do to the other side. So that cancels. What do we have here? What is 175 plus 70? X is equal to 2450. To get x alone, let's divide. Because it was attached by multiply, we'll divide. Okay. So interpret that. That fulcrum should be how far from the kid? 10 feet. Okay, and we know it's feet because that's the unit that our measurement was in up here. Feet, that's the only thing we have been talking about unit-wise.